Hey, Course 3, Lesson 16 is exploring a type of number that honestly I could really use the review on. Sometimes I forget what on earth are we talking about when it comes to the irrational numbers. We learned about real numbers, and the real numbers are really all numbers. They're the numbers that can be shown on the number line, which is pretty much any number you've used. You can use that symbol, or you can just call them the real numbers. And then within that, remember, real numbers can be shown on a number line, are the two main types: rational, which again we've learned, which means they can be shown as, a fraction, or they can be shown as having a divisor, like 2 can be shown as 2 over 1, or 0.5, 1 half. These are all rational numbers. They come out to a defined number, even if it's not a whole. 0.5 or 1 half, that's all it is. It's a full pizza. We know exactly how much it is. Irrational, still a real number. We can actually show it on a number line, but we can't completely define it. I mean, irrational would be like the square root of 2. It never really ends. Why don't you type that into a calculator quick? I have to check if my calculator... Yep. Square root of 2 is ugly. There's no repeating pattern. There's just a bunch of decimals going on, and they won't end. They don't terminate. That's what makes them irrational. I can't really show them, and I certainly can't show them with a divisor like a rational number. So that's what we're talking about when we're talking about the irrationals. Now, the reason we can put them on a number line is, I just typed in square root of 2, and it was 1.4 or something like that. So I know that the square root of 2 belongs somewhere between 1 and 2. So they show that. They show square root of 2, 1.4. If this is about halfway, then square root of 2 belongs right here, right? 1.4, not 1.5. If I type in square root of 3, it's still not going to be 2. It's 1.7, but it's getting closer. It's over half now. Square root of 1 does terminate, and of course square root of 4 is nice and even, it's 2. So those are rational numbers. But these irrationals, we can still show them on a number line. We know where they belong, we just don't know what they are completely. So we know the where, we don't know the what. Let's try using a calculator to find square root of 8. Right? Because in example 1 here, they ask which number is irrational. And if we type in 8 square root, it looks irrational. It doesn't seem to terminate or have a pattern of any kind. So I can't show that as a rational, number with a divisor. Square root of 8 is actually an irrational number. The cubed root of 8 is 2, but the square root with an understood index of 2, that's irrational. These are actually all perfect squares. Even the square root of 0 technically is 0. So these are the real numbers because they can be shown on a number line. All right. And lastly, so we could order these least to greatest, deciding 0, of course, is the least. And then to find, the way I would do this is I would go 5/9. Well, 5 divided by 9. Okay, keep in mind that that comes out to a decimal of just a little over a half. And then I would do the other ones, like square root of 5. You can just use a calculator to figure out the order of these. Square root of 5 is 2.23. So that one's going to be way up here. That's over 2. Less than 3, which is the biggest, but more than 2, and the rest are pretty simple here. That's how I would do that. Now, how would I find the length of a square? the side length of a square if I know the area. We're going to need this for the last example. Well, if I know the area, then I know square root that is going to be one side. Why? Because it's also true that to get to the area, I had to square the s. So square rooting gets me to just s. Such as if the area of a square is 4, I could square root that area to find what the side length is. Because then 2 times 2 would get me back to that area. So if the area is an annoying number like 2 centimeters squared, and we need to know the length of a side, we would square root that and say our answer is square root of 2, yes, an irrational number for an area, centimeters. It's an actual length. You know, if you took a ruler to this, it would be somewhere around 1.4. Okay, but you wouldn't actually know the exact measure, which is interesting. Letter A, if a real number is not rational, it's gotta be, I believe, there's no other choice. One more time. A not rational number, we add the prefix IR and call it an irrational, because it's not rational, okay? Why don't you do the rest of these? I think you'll be just fine.